Hello, welcome to the HR Diary. In this video, I'm going to show you how simple it is to use Minitab to run descriptive statistics. Descriptive statistics is the first level of data analytics. Descriptive statistics answers what happened by describing or summarizing raw data. I will not only demonstrate how to run descriptive analytics with Minitab, but I will also interpret each of them. As you can see, I have got Minitab open on my computer. You will notice that I have no data here. Now, I'm going to show you how to import an Excel file of data. To do that, go to File, Open, and find where your Excel file is. Click on the file and click Open. You will see that your Excel data has been opened in Minitab. When you import data from Excel, Minitab want to know a couple of things. If your columns have names here, tick data has column names. It is important to have column names like this so that you know what that data is. Minitab also wants to verify that it has read your data correctly. In each column, you have a choice of formatting it as numeric, text, date, time. Employee name is text, so text is correct. Date join is date, so date is correct. Age and salary are numerical data, so numeric is correct. Now that you have checked the data, click OK, and Minitab will give you all of your observations. So now all your observations, your data from Excel has been exported here. Now look at the column headings here. Notice that C1 has a T there. This is because these observations are text. C2 has a D because these observations are in date. C3 and C4 are just C3 and C4 because these observations are in numbers. Now, let's run descriptive statistics on this data. To do that, click onto Stat and then Basic Statistics and click on Display Descriptive Statistics. Then click on Salary because I want to run descriptive statistics for this variable, salary. And click Select. When you click Select, salary move on to the right panel at the variables there. Because this is the salary is the variable that you want to analyze. Next, we need to tell Minitab what statistics we want it to calculate for this salary variable. To do that, click on Statistics. As you can see, Minitab has almost every descriptive statistics that you can possibly calculate. You can just take those statistics that you want Minitab to calculate. The most commonly used statistics are the mean, standard deviation, the first quartile, median, third quartile, the range, and the mode. In this example, I will click onto all because I want to explain to you and interpret all these descriptive statistics. So after clicking onto all, click OK. Next, click graphs and tick everything because I want Minitab to display all these graphs, the histogram, the individual value plot, and the box plot of data. Click OK and click OK. Here, as you can see, Minitab has generated all the descriptive statistics. See, you have it here. Let me drag this lower. So you have all the descriptive statistics. Everything that I selected are there. The mean, the standard deviation, the sum, minimum, Q1, median, mode, skewness, ketosis. And it has also generated the graphs for this salary data, the histogram of, let me make this smaller. All right, the graphs, the histogram of salary. So the statistics is here. It has generated the histogram and histogram with normal curve for the salary variable. It has also generated the individual value plot of the salary variable, and it has generated the box plot of salary. So this is I have shown you how to generate descriptive statistics with Minitab. In this section, I will show you how to interpret Minitab descriptive statistics and graphs. On the left table are my data. On the right are the descriptive statistics and graphs generated by Minitab. I will show you how to interpret these descriptive statistics and these graphs. Variable. Minitab has generated the descriptive statistics for the variable called salary. So in this example, the only variable I asked Minitab to generate is salary. Total count is the total number of observations. In this example, there are 16 observations. N is the number of non-missing values. In this example, there are 16 non-missing observations. N asterisk is the number of missing values. In this example, there are 0 missing values. Cumulative N is the cumulative count of the number of observations. In this example, the cumulative N is 16. Percent is the percentage of observations for a variable. In this example, percent is 100 for the salary variable. Cumulative percent is the cumulative sum of the percentages for a variable. In this example, cumulative percent is 100 for the salary variable. Mean. Mean is the average of the data, which is the sum of all the observations divided by the number of observations. In this example, the mean is 1621. And how you actually calculate it is to take the sum of observations, which is this value here, divided by the number of observations, which is this value here. And this is the Excel formula to calculate mean. Standard error of mean measures how well a sample represents the population. In this example, the standard error of mean is 66.4. This means that if we took multiple random samples of the same size from the same population, the standard deviation of those different sample means would be around 66.4. The Excel formula to calculate standard error of mean is this. TR mean. This means trim mean. TR mean is the mean of the data without the highest 5% and lowest 5% of the values. In this example, the trim mean is 1630. When the data contain outliers, the trim mean may be a better measure of central tendency than the mean. Standard deviation here tells us the average distance that a value lies from the mean. In this example, the standard deviation is 265. Standard deviation are expressed in the same units as the mean. So in this example, these are expressed in dollars. Standard deviation is useful when comparing the spread of two separate data sets that have approximately the same mean. A low standard deviation indicates that the values tend to be close to the mean of the set. This is the Excel formula to calculate standard deviation. This is the coefficient of variation. This describes the variation in the data relative to the mean. In this example, the coefficient of variation is 16.39. The coefficient of variation is adjusted so that the values are on a unitless scale. Because of this adjustment, you can use the coefficient of variation instead of the standard deviation to compare the variation in data that have different units or that have very different means. The larger the coefficient of variation, the greater the spread of the data. Sum. Sum is the total of all the values in the data set. In this example, the sum is 25940. This is the Excel formula to calculate sum. Sum of squares. Sum of squares represents a measure of variation or deviation from the mean. In this example, the sum of squares, this is the sum of squares. This is calculated by squaring each value, then summing those squared values. So this is how you calculate sum of squares. A higher sum of squares result indicates a large degree of variability within the data set. In analysis of variance, the total sum of squares help express the total variation that can be attributed to various factors. Minimum. Minimum is the lowest data value in a data set. In this example, the minimum is 1080. And this is the Excel formula to calculate minimum. Q1, which means quartile 1. Quartiles groups data into 4 equal parts with 3 points. The first quartile, Q1, Q2, and Q3. Q1 is the 25th percentile, and it indicates that 25% of the data are less than or equal to this value. In this example, Q1 is 1462. And this is the formula to calculate Q1. Median. Median is the middle number in a sorted list. If there are even number of observations, then the median is the average of the two middle values. In this example, the median is 1640. Median is excellent for skewed distributions, and it is a robust measure of central tendency because it is not influenced by outliers. In this example, here, these numbers here, sorted numbers, the median is the center number here, which is 35. If you want to calculate median with Excel, this is the formula to calculate it. Q3. Quartiles groups data into 4 equal parts, as I mentioned earlier, with 3 points. This is the Q1, or you call it lower quartile, or 25th quartile. Q2, another name for it is 50th percentile or median. And Q3, another name is called 75th percentile or upper quartile. The third quartile is the 75th percentile, and it indicates that 75% of the data are less than or equal to this value. In this example, Q3 is 1805, and this is the Excel formula to calculate Q3 or quartile 3. Maximum. Maximum is the highest data value in a data set. In this example, the maximum is 2030. One of the simplest ways to access the spread of your data is to compare the maximum here and the minimum. If the maximum value is very high, investigate the cause of the extreme value. This is the Excel formula to calculate the maximum. Range. Range is the difference between the smallest and largest value in the data set. In this example, the range is the maximum minus the minimum, which is here. This is the maximum value minus the minimum value, and you get the range 950. The range represents the interval that contains all the data values. The bigger the range, the more is the spread of the data, and vice versa. Because the range is calculated using only 2 data values, it is more useful with small data sets. This is the Excel formula to calculate the range, the maximum minus the minimum. IQR. IQR stands for interquartile range. Interquartile range is the distance between the first quartile, Q1, and the third quartile, Q3. So this is the interquartile range. As the spread of data increases, the interquartile range becomes larger. In this example, the interquartile range is 3, 4, 2. Right? So the interquartile range is Q3 here minus Q1. You get this number. Mode. Mode is the observation that appears the most frequently. In this example, there is 1 mode, and the mode is 1500. This is the Excel formula to calculate it. And for mode, also displays how many data points equal the mode. In this example, n for mode is 2. This means that the mode 1005 appeared 2 times. Skewness. Skewness is a measure of asymmetry of the data distribution. A value of 0 indicates a perfectly symmetrical distribution here. Positive skewness means positively skewed, and this is how a positively skewed curve looks like. Negative skewness means negatively skewed, and this is how a negative skewness curve looks like. Here, the skewness is negative 0.37, which means it is negatively skewed. This is the Excel formula to calculate skewness. Kurtosis. Kurtosis is a measure of the flatness of the distribution. A normal distribution has a kurtosis value of 0. So this curve here is a normal distribution, and it has a kurtosis value of 0. A positive kurtosis indicates a relatively peak distribution. sorry, peak distribution. This is a positive kurtosis. A negative kurtosis here indicates a relatively flat distribution. Here, the kurtosis is negative 0.14, which means it is a relatively flat distribution. This is the Excel formula to calculate kurtosis. This is the formula to calculate kurtosis. MSSD means mean of squared successive differences, and this is also used to estimate variance. Next, I will interpret the graphs generated by Minitab. Histogram. A histogram represents the frequency of data. This is the histogram. It represents the frequency of data values in each interval with a bar. Use a histogram to assess the shape and the spread of the data. You can use a histogram of data overlaid with a normal curve. This is a normal curve to examine the normality of your data. A normal distribution is symmetrical and bell-shaped. All right, a normal distribution is symmetrical and bell-shaped. Histograms are best when the sample size is greater than 20. Here, outliers are isolated bars at either ends of the graph. So this is an outlier. Multimodal data have multiple peaks, also called modes. Multimodal data often indicate that important variables are not yet accounted for. So here there is 2 peaks. All right, so this is a multimodal data. This is an individual value plot for my variable salary. Individual value plot displays the individual values in a sample. Each circle represents one observation. Use an individual value plot to examine the spread of the data and to identify any potential outliers. Individual value plots are useful when you have relatively few observations of less than 50. Examine the spread of your data to determine whether your data appear to be skewed. When data are skewed, the majority of data are located on the high or low side of the graph. Boxplot. This is a box plot of my variable salary. Use a box plot to examine the spread of data and to identify any potential outliers. Outliers are easy to identify on a box plot. On a box plot, the asterisks here denote outliers. Outliers, which are data values that are far away from other data values, can affect the results of your analysis. Try to identify the cause of any outliers and correct any data entry errors or measurement errors. Consider removing data values for abnormal or one-time event. Then repeat the analysis. When data are skewed, right skewed or left skewed, the majority of data are located on the high or low side of the graph. Okay, that's it. I've shown you how to run and interpret descriptive statistics with Minitab. I hope that you found this video useful. Don't forget to like, share, and subscribe to the HR Diary channel.